Today, I'm going to show you not just what working code looks like, but a method that will help you get rid of the chaos in your mind and learn how to create solutions on your own. You won't just be able to follow along with the video, but you'll learn to think in a way that even when you turn off the screen, you'll be able to build the logic yourself and explain how it works.
When I start solving problems, I usually begin with the first phase, which is also called fishing. The idea is to fish out the main keywords from the problem statement that will help me later when writing code. Here, I realized that the data structure we'll be working with is a string, so we'll be doing something with characters. Moreover, we have string 1 and string 2. So we have two sources of data. This already gives me some understanding. What next? Merge the strings by adding letters in alternative order. Merge is another keyword that helps me understand that we will be doing some kind of merging. So here we have the first string, the second string, and we will be doing some kind of merging. Alternating order is a very important keyword, and here I want to share how I usually approach this. That is, when solving problems on LeetCode or preparing for interviews, you need to understand that there are certain keywords you just need to know. So with alternating order, you have two ways to solve the problem. First, if you're at an interview and you don't know what it means, you can clarify with the interviewer what it means. If you're solving it on your own, then before you start writing code, you should thoroughly and completely understand what it means, because I can draw an analogy. Imagine you want to renovate your home and you want to use laminate flooring in your bedroom. You call some contractor and tell him, I want to lay laminate in my bedroom. As a builder, based on the requirements you've given him, he understands that to work with laminate, he'll need tool 1, for example, and tool 2. And he knows how to use them. That is, he understands what needs to be done with tool 1 and tool 2 so that you end up with laminate flooring in your bedroom. It's the same thing here. You, as someone who regularly solves problems on LeetCode or works with algorithms, will also have your own personal set of tools and techniques that you will turn to when working on various types of problems. To understand which tool we should use and how exactly we should use it. And as you study problems on LeetCode and prepare for interviews, you'll keep adding more and more tools to your toolkit. When you actually get to the interview and hear that keyword, you'll already have an understanding in your mind of what it means and how you can work with it. In other words, this connection between the tool and how to use it, tools and how to use them, will keep growing for you as you gain more experience. If we move directly to what alternating order is here, as you can see, when I study all these problems, I write out absolutely all the solutions in this structured way, and I record these different keywords, different tools, and so on, in a separate glossary. And I've already added alternating order there as well. Alternating means, for example, we have string 1 and string 2, and alternating order is when we take, as you see, the first character from the first string, then the first character from the second string, the second character from the first string, the second character from the second string, and so on. That's why we end up with A1, B2, C3 here, and 45 gets added as a tail at the end. This is how I organize all the keywords that I come across while working on these problems, and in this way, when I later encounter some keyword that I've already used before and it's already here, for example, I don't know. When working with trees, I come across alternating order. I'll already have this tool at my disposal. I'll pull it out of my inventory and already know how to use it. That's why I recommend that you can do exactly the same. When here we're told starting with word 1, so we understand that we'll be taking characters from here. And this first one, the first string, will be our starting string. So first we'll take from the first word, then from the second word. Next, if a string is longer than the other, or in other words, if one of our strings happens to have a greater length than the other string, I notice the keyword if. This word, if, is important because it indicates a condition that we need to consider. We will therefore pay attention to this condition as we proceed. Check the length of this string and append the additional letters onto the end of the merged string. Here's another keyword, append. If you don't know it, you should learn it as well. I've written it down too. Append is like attaching a character to an already existing string. If we have an empty string called result and we want to append A to this empty string, that's what append means. We will be attaching it to an empty list. So, as you can see, our characters will be stored as a list. There will be the first character in the list, then the second character, and so on. Using this append construction, we will add elements from our strings. So, from everything we've just read, it's already clear. we have string 1 and we have string 2. We need to merge them into some third string. And the merging will start from string number 1. And we also have this condition. If one of these strings is longer than the other, then we will need to add the remaining part as a tail here at the end to make sure nothing is left out. Here, by using this fishing principle, I managed to catch these important keywords: append, alternating order, merge, and so on. And now I have some understanding of what will be here, specifically the code writing itself. Here I want to show once again that I have completed the first step. I analyzed the keywords. And in the end, a kind of puzzle has come together for me. So here I have the first puzzle made up of keywords, and then I have some other keywords that I will need to transform into code. So what do the next two lines mean? How am I going to write some logic? And then I will move on to the main principle number 2. In addition to the steps, I break the task itself into some small pieces, which are much easier to write than coding for a huge puzzle like this all at once. That's why I usually break the code into small pieces and write them separately. So I'll have separate logic for the if statement. I use separate logic for working with these two lines, handling each one individually to ensure clear understanding and precision. Afterward, there will be careful processing of the result itself. By organizing my workflow in this way, I'm able to break my work into 3 distinct and manageable small blocks, which helps me maintain focus and efficiency throughout the process. And I will write them separately. So first I'll write some kind of loop, then some logic, and then I'll process the result. And in this way, I will make small progress, step by step. This small progress will constantly motivate me, showing that I'm doing everything right. And in this way, I also avoid making mistakes. If I try to write a big solution all at once, the chances of making a lot of mistakes are very high. If I write in small pieces, like little puzzle pieces, there will be much fewer mistakes. That's it. And after solving this particular problem, I'll have some additional useful words, expressions, or phrases like these in my toolkit. In this way, we will carefully go through all of the problems, as well as the complete list of tools that we will be using. And when we finish all of the problems from LeetCode 75, you will have a large number of useful tools and techniques that you can take with you to interviews or use to solve problems on LeetCode on your own. So we've finished the first phase with the fishing, now let's move on to the second phase. The second phase is about writing as much code as we possibly can, based on the results and findings of our first phase, which was essentially our fishing expedition. The first thing we can do is naturally figure out what we need to initialize. In other words, this is about creating and not targeting data for initialization. This isn't some kind of logic, but this code can be written next. It does not require any super complicated or difficult actions from us. So since we are going to be merging our characters into a single string, here we will use a tool like a list, and each character from this string we will merge into the list. In other words, we will take each character one at a time and add it to the list so that later we can join them all together into a single string. That's why we create a variable called result, making it completely empty so that later on we can store things in it. These are our characters like A, B, C, or 1, 2, 3, and so on. So moving on. I understand that I'm going to be working directly with strings. Specifically, I'll have 2 separate loops that will allow me to go through each individual string. And from each string, I'll be able to process it. I'll be able to extract the characters one by one in alternating order. That's why I'll create 2 more variables. First word index and second word index, and set them both to 0. Because these indices will point to the first characters in our strings. Here, I want to make a small note that in this course I'm not covering the basics of the Python language or the fundamentals of programming. So you should already have a general idea of what a loop is, what a string is, and so on. Next, what else can I do at this stage? I always, as a rule, immediately look at what we need to return. Here, it says return merge string, and from this, I understand that we will be merging everything from word 1 and word 2 into a single list. But we need to return a string, so right now our result is a list, but the result should be returned as a string. And here we come to another tool, a technique that allows us to convert a list into a string. So right now it's not clear how we'll do this logically, but at phase 2 I understand that we'll be merging all the characters from word 1 and word 2 into a list and then converting it. In Python you can turn this list into a string using the join construction like this and pass the result here. I also made a note of this for myself when I was learning Python. It's not my native programming language. My native programming language is Kotlin. But when I was studying Python, I also wrote down these kinds of constructions, using it as a tool. With this kind of construction, I can turn the characters that are in the list into a single string, and that's how it works here. That's how it works. So we pass some list here inside the quotes, and as a result, we get a single string here. So here, this is the first thing we get. These quotes inside the double quotes here, what we have is a separator. As you can see, I've marked it here. If we don't write anything here, we just get a single string like this, without any spaces, without anything. We can put a space here, we can put a dash here, and so on. And then, between these characters in our list, there will be the separator that we set here. This is a convenient tool that Python provides us. That's why I also write down things like this in a separate file. Because it's clear that since I'm working with strings here, I can also work with strings in the same way. And in sliding window, for example, or other types of problems after interviews, or LeetCode. That's exactly why you really need to know about this join construction. And I made sure to write it down for you as well. And then, as I already mentioned, it will simply be another useful tool that I can use in all of my future problems. So, notice that we ended up with a logic where, using a fishing rod, we pulled out the keywords we needed. And based on these keywords, we already wrote some code, moved on, passed to phase 2, and extracted them. Here we also have some tools like join, as well as append and alternating. Now we will move on to phase 3, where we will actually write the core logic of the code. But note that with this kind of step-by-step algorithm, starting from the simple to the complex, we will be able to tackle and solve absolutely any problem. That is, we take the first step, analyze it, then the second step, then a small third step, and so on. Instead of trying to solve everything at once, with this approach we can solve absolutely any problem, no matter how complex, whether it's graphs, binary trees, and so on. Absolutely any problem can be solved using this method, by moving forward step by step, carefully breaking the code into smaller, more manageable pieces, and thoughtfully pulling out the tools we need. So keep watching the video. Let's move on to the third phase. And now we've reached phase number 3. Phase number 3 is when we actually start writing the logic itself. The logic itself is also divided into 2 parts. The main first part is working with the data that we currently have available. That is, in any given task we have some kind of data, whether it's a string, an array, or something else. It really doesn't matter what form it takes, but we have some data that we need to work with. We need to go through them in some way in order to perform certain manipulations. That's why the first part of the third phase is to properly organize a loop or some kind of iteration over the data we have. Since in our particular case we have 2 words which are both strings, here we can actually use a regular standard while loop and go through our words one at a time, continuing until they run out, that is, until all the characters in these words are finished. So in this situation we get a structure that is actually quite straightforward and easy to follow, and also simple to understand. That is, we have the very first word, and we start an array, then we begin a loop over the first word. After that we have the second word, and we also start a loop over the second word as usual. But isn't this a bit non-standard? Yes, when we have 2 words that need to be iterated over, usually we only have 1 word, so typically there's just a while loop over a single data source. But in this case we have 2 data sources. And here I'd like to draw your attention to the fact that when we write logic of these very loops themselves, you also need to be very careful here, because notice that in the conditions here it says that we're merging everything into one. All our characters, the symbols, and at the very end we add all the remaining ones. That's why here we need to pay attention to the fact that between these 2 iterations word 1 and word 2, we use this keyword, or. In this way, we can ensure and guarantee that we will proceed by carefully iterating through each element. All the way to the end, we won't stop our while loop when just one word ends. Instead, we will continue. If you don't put the keyword here, your loop will end unexpectedly. That is, if our first word ends, nothing else will happen. Here it says that all the remaining characters that weren't included in our main iteration should go at the end. That's why this particular wording lets us understand that we need to use or here. Again, I want to draw your attention to how important it is to truly understand the essence of the problem, because all these hints, all these little words, they all affect the code we write. And here, basically, we're just running a standard while loop. And next, we can move on to the next phase of writing the actual logic. Now I can remove the last one, this little piece here, and here we have the actual logic itself. Before we start breaking down the logic itself, note that we are continuing to make progress. That is, on the first step, we went through all our keywords. On the second step, we set up the initialization, and we created the result that we will be expecting. And on the third step, we launched it, this very loop. So step by step, we made 3 small steps and we made progress. What do we have from the puzzle's point of view? From the puzzle's perspective, we can color in the first piece, since our initialization data is already prepared. The second puzzle is that we more or less know what the result will look like. And the third puzzle is what we've already done, this very loop. And now we can move on directly to the logic. For example, this puzzle will be about the logic. And here again, I want to draw your attention to the very approach I use, which is to proceed gradually and in small steps. Clear progress. Now let's take a direct look at the code itself. Here too, everything is based on the keywords that we can find right here. Here. We already have this key phrase. If string is longer than the other, append additional letters. So we already understand that we have the word if, and here how exactly we will attach it. These symbols one after another in sequence, meaning that one iteration in the loop corresponds to this. This first symbol and this first symbol, that's one iteration of this while loop. And when we go down here after the first iteration, we have an A here and a P here. That's what we have. And we check if the value of the first index of the word is less than its length, meaning we haven't gone out of bounds. If that's the case, then we perform some operations. Why do we do this? Because here our loop is set up in such a way that it iterates through everything. For both words, for each of the 2 words. And if the first word has ended, then we shouldn't append anything anymore. There's nothing left to add to our result, so we need to check that the first word hasn't ended yet at this point. Then we'll add this character A to our result. If the second word hasn't ended yet, then we'll add a character from the second word to our result, right here. And in this way, we'll go through these characters. First, second, third. Until first one word ends, and then the second word ends. And here I want to draw your attention to the fact that the logic of the solution is such that even if you see our first word has ended, for example, the first word is completely finished, then the second word, it will keep adding its characters regardless, and this won't interfere with our loop continuing. So that's why we need the keyword here. And that's why we need to separate these 2 ands from each other. And in this way, our 2 words will be separate from each other. They can calmly iterate through their own characters and add their own characters to the overall result. So here, inside this block, inside this if, we add to our list, this result list. We add to our list the element where we are currently located. That is, if during our iteration we are currently at A, we add A to our list. If we are at B, we add B to our list, and so on. The same goes for the second word. And so using this kind of construction, result.append, we add all the characters that are present in our iteration. And this construction, word with square brackets and first word index, is simply It allows us to determine which character we need to retrieve. That is the character at index 0, the character at index 1, the character at index 2, and so on. So here, this first word index is a dynamic pointer that, of course, starts at 0. If you know how indexing works in arrays, first 0, then 1, then 2, well, that's what we have to do all the time. We need to keep incrementing this pointer, first word index, by 1 each time. That's why we have first word index plus equals 1. Because after the first loop, if we were here at A, we need to move on to the next character here where we have B. That's why we need to add 1 to 0, and 0 plus 1 equals 1. So it moves from here to here, and then we add 1 again, and 1 becomes 2. This simple process shows how each step increases the value by 1. Here, I want to share a bit of my own experience. It wasn't that easy for me to grasp this right away either. How to grasp the concept of a moving pointer and naturally understand and use it in my mind. But I want to say that when you start solving other problems to prepare for interviews, this technique where you have a pointer positioned at the first element and you need to keep moving it further and further, maybe even across several elements, will come up often with some data source and so on. This technique just needs to be practiced. I practiced it myself, and as for the percentage, I kind of figured it out for myself too. I have certain problems that helped me specifically train this tool, this technique. If you're interested and want to get these extra problems, just follow the links attached to this video. In fact, there are going to be many techniques. This is just one of them. If we look at all the other problems from LeetCode or something like that, you'll see that they're basically divided up. They're grouped by certain techniques, by certain patterns. For example, there's linked list, queue, sliding window, and so on. So all these things, all these algorithms are categorized. They're grouped either specifically according to techniques that are commonly used or by patterns that you need to use when solving algorithmic problems. And this is one of the most basic templates that I highly recommend you practice and memorize. When you have some pointer and you move this pointer from one element to another, you'll use it very often, so it's best to practice it. That's it. So this is how it looks. If you look at the actual solution from the code perspective, here's what we get while our first word hasn't ended or our second word hasn't ended. We move through our loop, and in this loop, we take our first word, a character from the first word, and add this character from the first word to the result. And we move our pointer here from 0 to 1, and we do the same with the second character. We check if the word is still present. If we can keep moving, then we take our current character. We add it to the result and move our second pointer. Now from P to Q, and here pay attention that at the very top I use word 1. That is, here we were clearly told to start with word 1. So we start adding characters from the first word, which is why we need to draw this block at the top. And then the second one, you see, that's why we have word 1 first, then word 2. Here, I've added these symbols for you again. This symbol, what does it mean here? We use tools, specifically the append tool, which I've already shown you. Here's the append tool, which adds things together. It adds characters to a string or to a list. That's it. And here we have another symbol, another tool, join. I talked about it as well. We'll need it when this loop is finished. This loop only ends when the first word is finished. And the second word, for example, might be a bit longer, but it also ends. Here's how the first iteration went. That's it. We finished here. We finished the first word, the character, and the second word. The second iteration started. We finished with the second character here and the second character here. The third iteration started. We finished here, and here's our first word, and it's done. There's nothing left here, that's it. But the second word will keep going like this, all the way to the end, attaching itself. And that's it. When the first word is finished, the second word is finished, the whole cycle is done. And this while loop is completed, just like that. And here we already convert our list using this join result construct. We convert it into a string. Because we need to return a merged string, and this string is what we return. That's the logic here. Let me summarize it briefly once more. Let me sum up. So once again, we've done an analysis. With the help of fishing, we extracted the keywords, then did the initialization and prepared the result that we will be expecting. Then we set up the loop and the logic inside the loop. So we've gone through 4 steps. We've completed these 4 steps, these 4 puzzle pieces. And as a result, we have come up with some kind of solution. Stay with me a little longer. I'll show you what else cool you can do. Another useful trick that I personally want to show you, which also really helped me in learning algorithms, is proper logging. Of course, there are a huge number of logs here, as you can see. And if you look at the solution itself, it definitely looks much bulkier compared to the actual solution. That is, in the actual solution, we don't have that many lines of code, but with the logs, there are definitely more. But why do I do this? I do this so that when I move down from this step to the lower loop, that is, I always put a log right after the loop starts running, because when the loop starts running, it's important for me to understand that my variables are working correctly. I need to know what values I'm dealing with. In other words, if you don't put in logs, you're working blindly. It's great if you understand everything, but when you're just starting to learn, all this confusion in your head kind of gets in the way of thinking clearly, makes it hard to make decisions, and properly placed logs help you organize the whole process of working on the algorithm. So take a look at how this looks. Here are my logs before anything else, and notice how convenient they are to read. For example, I output my first word in the log and show its length. Then I output the second word and show its length. So here, in the logs, I can already see what I'm working with. Then, in the loop, I output the current element and the current index, 0 and 0. Here I output the characters for each one. So you see the first iteration, it turns out that I have the character A and the character 1. I check in word 1 I have a, and in word 2 I have 1. Okay? So I understand that up to this point everything is correct. Next I have word validation. I check if this validation is working correctly. I see that the index of the first word is less than the length. We looked at the total length of my word, 6 characters. Here I check, yes, that's correct, 6 characters. Right now I'm at the first index. 0 is less than 6, so yes, that's why I have the opportunity to attach my current character to my result. That's why, first of all, I increment my pointer. This pointer that I am currently using here, I increment it by 1, and then after incrementing it, I attach it to the result. My first character, see this result append here, is also attached in the logs. It looks something like this. You see after I attached it, specifically after I attached it and incremented. This pointer of mine, I output it in the logs. I do the same thing with the second word, and as a result, here it is, Bedri. I see the result. So, as you can see, with this approach, I can fully observe how each character is appended to my result at every iteration. So you see, and then 1 and 1 by a 1 by 2, and I can see that my logs match the thoughts and goals I set for myself in my mind. That is, I can see that they are being inserted correctly in the alternating order specified here. Here's the alternating order I have. Yes, I have it. And I have it specifically in the logs, not just in my head. There you go. And with this approach, I wrap all these algorithms that solve all my tasks. Yes, of course, somewhere. In graphs or in binary trees, everything is much more massive and complex there, with a significantly larger number of elements and connections to consider. But with this kind of approach, and by applying these principles consistently, I am able to wrap things up effectively and efficiently, even in such challenging and large-scale structures. Absolutely everything. These little puzzle pieces. And this allows me to calmly analyze how my puzzle works. That is, with such detailed logs, I can understand whether this particular piece isn't working, or that one, whether the loop itself isn't working, or if some logic inside the loop isn't working, or if something is set up incorrectly. Like maybe the pointers are set up wrong. But with this kind of this kind of setup, these kinds of machines, large scale, serious ones, logs, I end up being able to see everything, how it all happens. Oh, I have a small mistake here. Yeah, you see, but at least I can immediately spot that there's some kind of error here as well. And even thanks to the fact that my logs are so detailed, I can more or less figure out where it happened. So you see it happened here and here, and apparently somewhere there the word ended and dropped out. And now I can already understand that most likely the error popped up somewhere when the word itself ended, and because of this error I had to rearrange the logs a bit. So I made them safer, moved them inside their condition. Still, it's easy to read. For example, here we have the first word, our first index, and the first character. Next we perform a check, then we increment our pointer and display the result, and in this way, as you can see, there are 4 lines each time. I can go through each individual element, you see, even bringing it to the point where I add these kinds of empty symbols or strings and I sort of group them, and as you can see, it's very convenient to read them, to create some empty spaces between them. So it's very easy to read, and if you're interested in me making a separate video about how I create logs, let me know. If you're interested in getting all the logs in general, like a file with all the logs so you can run it yourself, and see the solution to the problem, play around with it, and use my logs, then follow the link to this video. I will gradually upload all my solutions to problems, and all these solutions will be accompanied by these nice logs that you can use yourself. And this will help you understand the problems faster, meaning you can just open a problem, try to solve it yourself, and then, for example, run my code and see how I did it. Basically, you can see how I distributed these logs and play around with them directly in the code. And you can practice writing these logs yourself, because if you write such clear logs for yourself when you tackle more complex problems, it will help reduce the likelihood of making mistakes. In addition to these kinds of logs, I also write down, as you can see, for each task, I jot down some examples for myself. For instance, what is an alternative order? I write short, concise examples and clear definitions for your understanding. So, if you would like to get this file, which contains all of these helpful notes and explanations for the current task, just follow the links provided below. This will allow you to access everything you need for reference and review at your convenience.
Right now, open the link in the description. There, I've gathered everything that will help you understand faster. The full code from the video, a version with logs, and additional materials. There are also practice problems to help you reinforce the template in your memory. If you want to learn together with others who are also working through LeetCode, subscribe to the social networks and join our communities. It's both easier and much faster to learn in a group. If you enjoyed this video, don't forget to subscribe to the channel. The more subscribers and activity there are, the faster new videos will be released.